So let us first try to understand why do we need digital signal processing. So this way we may have a motivation to learn things and the subject with enthusiasm. So in control of a process, we normally see that the first stage is in the form of sensors and transducers, which deal with analog signals. So the input that is going to be fed to this processor from the sensors and transducers will be analog in nature. Moreover, actuators, plant process being controlled also deal with analog signals. So the output that the processors will be giving to the actuators or the devices that are required to be controlled will be fed with analog signals. On the other hand, a digital processor understands the digital language, that is zeros and ones. So naturally this gives rise to a question that since the input being sensed or measured is analog in nature and the output to control the plant or process should also be analog. That is what they understand. If you feed the plant or process with digital data, you may get nothing. Now, both the sensor output, which in fact is the input to the processor, and plant input, which is the output from the processor, are analog in nature. Then why do we use digital processor, which understands digital language and not analog language? So why do we not stick to analog processor where we don't need to convert analog signal to digital forms and vice versa? So if you see this figure, since we are going to feed the processor with an analog signal, this processor understands the language zeros and ones, which means that we eventually will require to convert this analog signal to digital form. Then the process or the plant also understands analog signal, and the DSP now has, after processing the signal, has digital form, and thus again you will be required to convert this digital language back to analog form in order to communicate or converse with the processes. Well, in many technical areas we have for very long been interested to perform set of operations based on the real world surroundings to obtain desired outputs. Moreover, we always desire to know to not only have these operations or outputs as accurate and precise as possible, but also have a scope of flexibility or extension in them. In the past, before the advent of DSP, analog signal processing was prevalent. Analog signal processors normally uses electrical and electronic devices for their implementation. The examples of the electrical and electronic devices you all know about, which are employed in the ASP or analog signal processors, are the resistor, capacitors, transistors, op amps, inductors, etc. So this means that to perform the set of operations as discussed above, we not only have to implement a dedicated hardware, which means no flexibility at all. So if you are going to incorporate, or if you're going to make this hardware dedicated, then in that case you won't be having flexibility, since the to perform different set of operation or change rules on the incoming signal, it is required to change the hardware. And some of you who may have a slight experience working on hardware know the difficulty in replacing even a small resistor in the PCB. So in addition to no much flexibility in analog signal processing, you know what implementing a hardware means in terms of space as well. For instance, to perform a complex operation means a complex hardware is implemented. As a result, more space is required, and thus analog signal processors had increased physical dimensions and increased cost. In short, the analog signal processors were able to apply a very limited set of rules. On the other hand, engineers and scientists were always interested to anyhow implement these set of rules mathematically on the input signal and to mold these input signals according to their will. Finally, in around 1960s and 70s, the digital signal processing was born, and with the advent of the DSP, many processes which can never be thought of to be controlled using analog processors became possible, and this brought a major impact in many technical and research areas. So digital signal processing incorporates digital elements, which adds to its name digital. And these digital elements uh, So by the term digital elements, we mean digital computer or digital hardwares like a microprocessor or microcontroller. So these elements along with the algorithm or set of rules process the input signal accordingly. This process of making the processor work based on the algorithm makes the DSP quite flexible. Thus, the flexibility offered by the digital signal processor had been possible because of the algorithm that sits on the digital processor, and this algorithm or the set of rules, in other words, are written by the user on software platforms according to the will of the user. This means that any sort of mathematical operation can be carried out on the incoming signal to the processor simply by writing and placing the algorithm on the digital processor. These mathematical operations or set of rules are written according to the operation the DSP is required to control. In essence, if the user decides to change the type of process to be controlled, he simply have to change the algorithm on the digital processor instead of changing any type of hardware. But in case of analog processor, to alter the output for same input, the change in hardware is required. In addition to the processing power and flexibility of DSP, if we talk about the digital storage, the data acquired in analog form from the sensors or transducers, when converted into digital form, can easily be stored for future processing. So one big advantage that we see in digital storage technology is that day by day the storage capacity is increasing. The illustration here demonstrates the same. So it's written just one micro SD, which is shown by this tiny sized devices at the most bottom. So if you see if you're able to see these two devices, which are very small in size, are the micro SD card, and they are capable of storing more than the rest combined. So if you talk about the storage of the remaining devices other than the micro SD, so all the devices storage combined will be equivalent to the uh, storage capacity of these micro SD. And if you look at the images below, so they show the advancement in storage that took place at extremely fast pace for the last 2 decades. In fact, if you talk about this image in black and white, so here it shows a box. So this box is in fact a storage device which was capable of storing only 5 MB at that time. So this is about 1956, and this device seems to have been brought through an aeroplane. If you talk about the advancement in the storage in 2005, so we came up with a storage device which was very small in size, shown here. So it's equivalent to the fingertip, and this micro SD was capable of storing 128 MB of data. While approximately a decade later, then the same micro SD had increased storage of about 128 GBs. Then 2 years later, we came up with another storage device which was capable of storing 256 GB, and this is in fact day by day increasing. While if we talk about the analog data storage, which were very limited in terms of type as well as size, this means that the analog data once acquired will have to be subsequently processed without being stored. Furthermore, the storage capabilities of digital data without noises is an added benefit. The reason that digital data cannot be easily corrupted by noises is its two states. So it can take only 0 and 1. Since digital data contains zeros and ones, the alteration in digital data will mean that some values which were zeros in original data got changed by 1, while some ones changed by 0, which is something not that easy as like the case of analog signals. So we shall not be talking about this in much detail now, and leave this for the later studies. Now, if we talk about the digital transmission, so this part is amazing using DSP. The data processed by DSP is digital, which can be transmitted at long distances without noises. This advantage gives an extra benefit that data may not necessarily be processed where it is being acquired. So you may be acquiring the data at some place, and the digital processor would be sitting somewhere else, maybe somewhere far, and the data acquired at one place can be sent to the digital processor and then received back without noise being overlaid during transmission. And moreover, multiplexing the data may give way more benefits, whereas the single DSP or the digital processor may be dealing with multiple inputs, which these multiple inputs may be acquired at different places at the same time. So you might be having, for example, shown here as the different inputs acquired from different locations, and this will be using multiplexer fed to the same processor, and that processor will be processing each of these inputs, producing output, sending that output back to where the input originally came from. So this gives much more power to employing the digital signal processing techniques. So this is all for today. If you have questions, you can ask me. You can post questions on Google Classroom, and if you feel shy, you can send me questions on. You can email me the questions on my email ID, or you can ask me on Google Meet as well. So thank you.